So in our last video, we learned about how we could tell how strong, if it was a strong and acidic or if it was basic based on the H and the OH concentrations. Now we're going to talk about the pH scale, which you've probably heard about in science at some point in your lives. The pH scale represents the solution's acidity. So the pH is equal to the negative log of the H plus concentration. So we are using the log button on the calculator. We don't have to do log base of anything, it's just log base 10. Use the button on the calculator, that's all, okay? So we just have to make sure we type it in correctly, otherwise you'll get an error every time. The significant figures with this is more difficult than normal. When rounding to significant figures, the number of the decimal places for a log must be equal to the number of the sig figs in the original number. So if it came up with 2 sig figs in the original number, that means you're going to have 2 decimal places on your answer. Okay? That's just something very difficult with the sig figs. You're like, I finally mastered sig figs, or you're like, I've never done sig figs right before, and now I throw this at you too. We'll see how it goes. The pH scale, you've seen it before, probably. 1 through, or 0 through 6.9-ish is acidic, 7 is neutral, and then 7.1 through 14 is basic. So we'll deal with this in our activity that we'll do, where you will be testing and you'll see what pH things are of all these kind of different things. So it's a number to tell you whether it's acidic or basic, just like the OH and the H plus were. Okay, so with example 5, we're going to use our negative log equation to solve for the pH of each of these values. So let's just think about A first. I'm going to do B second, so don't worry about that right now. But for A, a solution has H plus is equal to 1 times 10 to the negative 9 molar. Okay, so remember our equation is the pH is equal to the negative log of the H plus. So, to plug in, pH is equal to the negative log of the H plus. So we got 1.0 times 10 to the negative 9. Okay. In the calculator, if you have my calculator, you have to do it this way. If you have a calculator where you can see the whole equation that you're plugging in before you hit enter, you can type it in, negative, hit the log button, put in the number, enter, and I'll do it for you. For my calculators, we have to go backwards. So in my calculators, are you ready? You're going to take 1.0, EE negative 9, get the number in there, then find the log button, and press log. And whatever your answer is, because of the negative sign, you're just going to make it positive. Okay? So, like when I did this, when I put 1.0 EE negative 9, hit the log button, I got a negative 9 as my answer. But then because of the negative sign in the equation, the pH is going to be a positive 9. Okay? There's no unit on pH, but we do have to round to those crazy sig fig rules, where the number of sig figs is equal to the number of decimal places. So we have 2 sig figs, 1.0 is 2 sig figs, so that means that our answer has to have 2 decimal places. And since it was just a flat old 9, I have to say 9.00 for my pH answer. Okay? So that's A. B is a little bit more, because for B, we are given the OH concentration this time. Okay, well on our equation we don't have OH, we only have the H plus. So we need to switch it. So we have to use the KW equation from video 2 in order to get the H plus. So the KW equation, remember, is H plus times OH minus times 10 to the negative 14. So we need to find the H plus concentration, we need to take the 1 times 10 to the negative 14 divided by our 1 times 10 to the negative 6. So the H plus, when we divide that out, is equal to 1 times 10 to the negative 8. Okay, so now that we know the H plus, now we can use our log equation. So plugging in negative log of 1 times 10 to the negative 8 in the calculator, 1.0 EE negative 8, hit the log button, and I got negative 8, so from that negative sign I'm going to know that my pH is going to be positive 8. Rarely, if not ever, do you ever have a negative answer for your pH. Last but not least, crazy sig fig rules. We had 2 sig figs to start, so that means we need 2 decimal places on our answer. We did not, I just realized, label if these were acidic or basic. Well, if it's a pH of 8, that's above 7, so that means it's basic. What about for A? A had a pH of 9, which is also greater than 7, so it's also basic. There we go. Now we know how to tell acidic or basic. These other equations might be helpful to you. You could also throw in, if you wanted to, on this section, because you're probably going to look at this a lot to solve, you can throw in the KW equation that we used the other day, because sometimes people forget about it. They don't have it sitting right here. These will be given to you on a test. You don't have to have these equations memorized. You just have to know how to use them. So we just have to, we're probably going to have to use these equations when we have 2-step problems, which B was just a 2-step problem that I made you do. When you are trying to find like the pH, but then you're given the OH. Well, then there's no OH in there, so you're going to have to do a couple steps. POH is the subtraction from 14 of the pH. And so I really like this equation right here, because adding and subtracting to me is a whole heck of a lot easier than doing all these other things and using scientific notation in a calculator. It's a personal preference to use that one, but what's nice about the 2-step problems with this is that there's 2 ways to get to the same answer. So even if you don't take the path that I take, we'll probably get the same answer still. Okay? That's what's really nice about this. So example 6, we're going to do one more 2-stepper, and then we'll be finished. So the pOH of a solution is 5.67, and we want to know the H plus of the solution. Okay, well, I'm given pOH, and I want to know the H plus. So looking back at the list of all the equations, is there an equation that has both of those in it? I see pOH here, I see pOH here, I see pOH here, but I don't see H plus in those. One thing I forgot to mention, everything on the left here, or sorry, these and these, they're solved for. So you don't want to use, like if I want to solve for the OH, I don't want to use this equation. I want to use the bottom equation, because then the OH is solved for by itself. Okay, that's tricky for some people. What I'm going to do first, since I was given the pOH, I'm going to use this middle equation I circled, because I can take 14 minus the pOH and get pH. And then from there, pH and H plus are related, so I can find it. Okay? So first thing I'm going to do is I'm going to take 14 minus the pOH, 5.67, and when you subtract that, you get that the pH is going to be 8.33, and that's the pH, sorry. And then, so now that I have the pH and I want the H+, well, looking back at the equations again, this equation right here has H plus solve for, and I could plug the pH in here. So, setting that up, the H plus is equal to 10 to the negative pH. So my pH is 10 to the negative 8.33. Okay, calculator time. This, you need to look, to use this equation, you need to look for the 10 to the x function, which is probably when you hit second and then the log button that we just used previously, okay, where it says like 10 to the x. So on my calculators, we have to type in 8.33, hit the negative sign, and then second log, and that will do it for you. If you have a calculator, like a graphing calculator or something where you can see the whole equation out, you need to hit that 10 to the x button first. But you still need to make the 8.33 negative. Okay? When you solve that out, so one more time, 8.33, hit the negative sign, not the subtraction, and second log button equals, if you need to, the H plus is going to be 5.0 times 10 to the negative 9 molar. Significant figures. I only have two sig figs here. This is like backwards of what we did with the log. So when you're doing the reverse function, which this is the inverse function of log, when you do that, the number of decimal places that you plugged in is equal to the number of sig figs total at the end. We use indicators to measure pH of different acidic and basic solutions. So this is an indicator chart that makes it easy for us to tell. We are actually going to be using the phenolphthalein, the bottom, the clear to pink, in class. But there's a whole range of pH indicators, and we are going to use pH strips in our lab to just test what the different pHs of different solutions are, and then we can look at an indicator chart to tell us what the color means. A convenient way is using that indicator paper I was kind of talking about, that where we hold it up and it tells us what the pH is based on its color that it turns. And no matter what you have in there, it'll turn that color if it's the right pH. The pH value can also be electronically measured with a pH meter. We don't do this in Chem 1, but we do try to do it in AP Chemistry, where it electronically measures a very more precise measure of the pH of the solution by using an electronic probe that's put into the solution, and it reads the H plus concentration and converts it for us. So we're going to be doing that in lab, not the meter, but the indicator paper. Okay, now make sure you do your pH calculations. Check your checklist for when it's due.